Cancer isn't one disease, it's more than 100, and they all start the same way, with a single cell that stops following the rules. This series is a plain language tour of the major cancers and how they're treated. Quick but important note up front, this is educational, not medical advice. If it's about you or someone you love, talk to a real oncologist. Today, the foundation, what cancer actually is, and why one misbehaving cell can become life-threatening. It all starts with broken instructions. Every one of your cells carries a DNA instruction manual that tells it when to grow, when to stop, and when to quietly die and be replaced. Cancer begins when mutations corrupt that manual. Two kinds of genes matter most. Oncogenes are the accelerator. When they're damaged, they get stuck on, telling the cell to keep dividing. Tumor suppressor genes are the brakes. When they break, there's nothing left to stop the growth. It usually takes several of these hits accumulating in the same cell, over years, before things go truly wrong. That's a big reason cancer risk climbs as we age. Mutations pile up over a lifetime. Scientists boil the behavior of cancer down to a set of shared traits, often called the hallmarks of cancer. A cancer cell learns to grow without any signal telling it to, and to ignore the signals telling it to stop. It refuses to die, dodging the built-in self-destruct program that healthy cells obey. It divides endlessly, bypassing the limit on how many times a normal cell is allowed to copy itself. It builds its own blood supply, growing new vessels to feed the tumor. It learns to invade nearby tissue and spread to distant ones. And, remarkably, it learns to hide from the immune system. No single trait defines cancer, it's a cell that has collected enough of them to break free of the body's control. Not every lump is cancer, and this distinction matters enormously. A benign tumor is an overgrowth of cells that stays put. It can still cause real problems, pressing on a nerve, a blood vessel, or an organ, but it doesn't invade neighboring tissue and it doesn't spread. A malignant tumor is what we actually mean by cancer. It invades the surrounding tissue like roots, and it can break off and seed brand new tumors in distant parts of the body. That single capacity, the ability to spread, is the dividing line between a growth that's a nuisance and one that's a threat. So let's talk about the step that makes cancer deadly, metastasis. This is when cancer cells break away from the original tumor, slip into the bloodstream or the lymphatic system, travel to a distant organ, and start a new colony there, most often in the lungs, the liver, the bones, or the brain. Here's the sobering part, the great majority of cancer deaths are caused not by the original tumor, but by this spread. A breast tumor is rarely what's fatal, breast cancer that has spread to the bones or the liver is. That's why catching cancer before it spreads changes everything, and why so much of treatment is a race against metastasis. Once cancer is found, doctors describe it with two numbers. Staging asks how far it has spread, usually running from stage 1, small and still local, to stage 4, meaning it has reached distant organs. Stage is the single biggest driver of both prognosis and the treatment plan. Grading asks a different question: how abnormal do the cells look under the microscope? Low-grade cells still resemble normal tissue and tend to behave more calmly. High-grade cells look chaotic and tend to grow and spread faster. Together, stage and grade turn cancer from a scary word into a specific, describable problem, which is the first step toward treating it. And that's where we're headed next. Remember, this is educational, not medical advice.